On this video, we're going to go through the Cisco native VLAN configuration. And this is just one video in a much larger series called GNS3 Labs for the CCNA certification. And so if that interests you, you should subscribe and check out the rest of those videos as well. In this video, we're going to look at the definition of a native VLAN, some other characteristics of the native VLAN. We're going to discuss the concept of the native VLAN mismatch, and then we're going to go through some basic configuration examples and demonstrate on GNS3. All right, the definition of the native VLAN. It is the untagged VLAN that runs across trunk lengths. The native VLAN is configured on both ends of the trunk, and it actually does not have to be the same on both ends of the trunk, as each switch is not aware of what the other trunk has configured as the native VLAN. The native VLAN is a per trunk, per switch configuration, and by default, VLAN 1 is the native VLAN. Now, other native VLAN characteristics, it is the one VLAN that traverses a trunk port without the VLAN tag. The sending switch omits the VLAN tag for traffic belonging to the locally configured trunk's native VLAN. And the receiving switch accepts the untagged traffic and puts it into its own native VLAN. The native VLAN is now primarily used for management traffic, and LLDP and CDP use the native VLAN as well. All right, now the concept of a native VLAN mismatch. If you do have a trunk with mismatched native VLANs, you will get errors, and those errors come from the CDP process. To do so, the best practice is to also not use native VLAN 1, and that's for security concerns. If you do leave it as VLAN 1, it leaves you open for an attack, because it gives the attacker the ability to guess that it's native VLAN 1s. So the best practice is to pick another unused VLAN and use that as the native VLAN on all the switches. All right, so now I've got GNS3 pulled up, and we're basically continuing where we were in the last video, which would have been the trunk video. And I've got the configuration that we're going to use pulled up on the other side here. Right now the switches are still booting up, but we're going to put this in, which configures the host name, then two VLANs. We're going to have an IP address on interface VLAN 10, but we're going to shut it down. And that is just to illustrate that we don't need to have inter VLAN routing to get this working. And then this is the access port configuration that we're going to use on switch 1. This is the access port configuration that we're going to use on switch 2 for part of the time. We do have IP addresses configured on all of the virtual PCs. So you've got the IP, the subnet mask, and the default gateway. And then this is the trunk configuration that we're going to go with for this lab. So we're going to allow all VLANs. We're using the .1 queue encapsulation. And then we're going to show what happens when you have mismatched VLANs. So on switch 1, we'll have VLAN 10 declared as the native VLAN. And on switch 2, we're going to have VLAN 20. All right, so now the switches are booted up, so I'm just going to apply the configuration. Then all of these IPs are already configured on the virtual PCs. Now I'm going to configure the two trunk ports on switch 1. All right, and then we configured the two trunk ports on switch 2, and we can see that we're getting all sorts of these spanning tree errors for native VLAN mismatch. And so let's look at what PC1 is able to ping here. So PC1 pinging 10.3, 10.0.0.3, which is going to be the virtual PC over here. And in order to do this, it would need to go across these trunks. But because we have this native VLAN mismatch, we are able to see. Let's put this down here as well. Okay, so that's going to be our verification command that allows us to see what spanning tree is doing. We can see that it is blocking on two ports for both VLAN 10 and VLAN 20. And so a spanning tree is blocking this. And we also get the CDP message for the native VLAN mismatch. All right, so that's what's blocking it. So what do we need to do in order to get this working? One easy way would be to just put everything in the same VLAN and then change the native VLAN on 2. All right, so I'm going to put these commands in to change the access VLAN that the virtual PCs in are on switch 2. And then change the trunk ports to have everything be in the same VLAN. Or then change the trunk ports to change the native VLAN to VLAN 10 as well. All right, and then we can see that we have port consistency restored, and it is unblocking. Show spanning tree summary. We can see that it's only blocking one port, right? And that's just because we have two ports between these two switches, which means it's going to block one of them. Now, virtual PC 1 can ping virtual PC 3. So All right, so that was a brief lab on the native VLAN. If you found this helpful, please consider liking and subscribing, and I'll see you in the next video.